All right, let's get right into this because DeepSeek just stopped a paper that, honestly, could completely change how we build AI. For the longest time, the strategy has been pretty simple, right? If you want a smarter AI, you just make it bigger. But we are really starting to hit a wall where that's just becoming insanely expensive. And this gets to a huge, kind of hidden problem. Even our most advanced models, the ones that feel almost magical, have an absolutely terrible memory. I mean, think about it. They are constantly forced to relearn the most basic facts, like Paris is the capital of France, every single time they see those words. It is just a wild waste of energy. Here's a way to think about it. When you hear the name Alexander the Great, your brain doesn't have to, compute who that is from scratch. You just, it's instant. But an AI, even if it's seen that name a million times, has to waste a massive amount of its processing power rebuilding that concept from all the little clues it has, every single time. It's like having a friend who has to figure out who Taylor Swift is from scratch every time you mention her name. So yeah, this isn't just about being slow. This inefficiency is a massive waste of resources. It creates this huge invisible wall, this bottleneck, especially when it comes to the single most expensive and scarce resource we have for AI, that super fast memory on the GPUs. So what's the fix? Well, DeepSeek's solution is called Engram, and the idea behind it is incredibly simple but really powerful. Just stop making the AI's main brain waste time on easy, repetitive facts. Let it focus its expensive, high-powered compute on what it's good at, actual thinking and complex reasoning. In this slide just illustrates that shift perfectly. The old way forces the powerful GPU to do absolutely everything, the hard thinking and the simple remembering. The new way is like giving that powerful core a massive, separate library, basically a cheat sheet that it can use for instant lookups. This frees it up for the tasks it was actually designed for. Okay, so how does this cheat sheet actually work under the hood? What's really clever about Engram is that it takes a really old school idea, something from the early days of AI, and combines it with some very modern, very powerful tricks. It's basically a three-step dance. First, the system spots these common word patterns. Think of phrases like United States or New York City. It does this using a classic technique called engrams. Then, step 2, it uses a super fast lookup system, like a digital address book, to instantly grab a pre-computed meaning blob for that phrase. And finally, and this is the key part, a smart gate inside the model acts like a bouncer, checking if that piece of memory actually fits the conversation before it lets it through. So, and this is the crucial point, right? This isn't about memory taking over the show. It's about memory acting as a smart assistant. The main reasoning brain, the core of the model, still has the final say. It decides whether to use the memory, tweak it, or just ignore it completely based on the context. It's a support system, not a replacement for actual thinking. All right, let's get to the results because this is where things get really wild and kind of counterintuitive. And DeepSeek didn't just test this on some tiny little model. They skilled it up and put it head-to-head with an equally powerful model that didn't have this memory system. So first, the obvious test. And as you'd probably guess, if you give an AI a better memory for facts, it gets way better at answering factual questions. On the MMLU benchmark, which tests knowledge on stuff like history and science, the Engram model jumped up a solid 3 points. Okay, makes sense. No big surprise there. But now here's the crazy part. Engram also massively boosted the model's performance on tasks that feel like pure thinking. I'm talking logic puzzles, multi-step reasoning problems. On the Big Bench Hard benchmark, it jumped up by a massive 5 points. It even got better at coding and math. Now that seems backward, right? Why would having a better memory make you a better thinker? Well, the explanation is actually, it's just so elegant. In a normal AI, the first few layers of the network waste a ton of their power just recognizing and reconstructing basic, common patterns over and over. By offloading that boring, repetitive work to the memory module, Engram lets the model's early layers start doing complex, abstract thinking much, much sooner. It's like giving the model extra brain depth without actually adding more layer. And you can really see this effect when you look at long documents. On the classic needle in a haystack test, where you hide one specific fact in a giant wall of text, the standard model found it about 84% of the time. The Engram model, an incredible 97%. By letting the memory handle all the small local patterns, it frees up the AI's attention to focus on the big picture. But honestly, all of those performance gains, that's just one part of the story. The biggest unlock here, the thing that could truly power the next generation of AI, is how Engram completely re-engineers the system's hardware needs. You have to see this. Get this. The researchers tested offloading a gigantic 100 billion parameter memory table. That is a huge amount of knowledge onto cheap, standard, regular old CPU RAM instead of that expensive GPU memory. And the speed hit, the performance penalty, was less than 3%. That is a massive deal. It proves you can bolt on these ridiculous amounts of memory without really slowing the model down. This fundamentally changes the game. For years, we've been bottlenecked by how much expensive, high-bandwidth memory we can cram onto a single GPU. This new architecture creates a world where the GPU handles the thinking, and you can add almost limitless knowledge using affordable, abundant hardware. It completely bypasses the memory wall. And DeepSeek even formalized this. They found this U-shaped sweet spot. They compared Engram to a standard mixture of experts model, or MO, which is all about pure computation. And it turns out 100% compute is wasteful. 100% memory is dumb. The best performing models have this hybrid approach, allocating about 20 to 25% of their total capacity to this fast memory, which proves it's just a fundamentally more efficient design. Ultimately, what Engram shows us is that the future of AI isn't just about making the models bigger, it's about making them architecturally smarter. By finally creating a clean separation between what an AI knows and how an AI thinks, DeepSeek might have just given us the cheat code for building the next generation of intelligence.